Now, before going into solving the problems in pipelining, you should understand how a pipeline is being constructed, what are the internal functional units and what are all present inside it. Then only we will be able to answer certain questions easily. So for some time, let's say for 1 or 2 videos, we'll focus only on how various pipelines are being designed. So this is the generic view. If you want to design a pipeline, we are talking about instruction pipeline here. Okay, there are various types of pipelining. Sometimes there is also pipelining done for data processing. In that case, what happens is we'll have a certain processing unit and we'll be sending in data and getting out the output from the other side. But here it is purely about instruction pipeline, which means we'll be sending instructions from one side and we'll be getting the completed instructions from the other side. Okay, now if you want to construct a m-stage pipeline, you should be able to divide the entire control unit or entire CPU into m functional stages which are independent of each other. Independent means one functional unit, when it is currently being used by an instruction, the other functional unit should be there should not be any problem in allocating the other control unit or other functional unit to some other instruction. Then only we can say that they are independent, right? So you should be able to break down the entire the CPU into m phases first. Then what happens is, when we pass the data into one phase, sometimes the data will come out fast compared to the other stages, and sometimes it might come out slow. That depends on what type of thing we are trying to accomplish in that particular phase. So what happens is, because of these uneven delays in the processing at every phase, sometimes we will not be able to handle the data which is coming out of the faster stage. In order to store that data, we have to have some registers, right? They are also sometimes called as buffers. So every stage, when in the real world, sometimes in the questions they might not give you the registers, but in the real world, when you are constructing a pipeline, every stage should have a buffer associated with that. So the generic view of a pipeline, if you watch it, it will be something like this. See this. Now this one is going to be let us say one phase. This phase will contain certain combinational logic. Let's say that C1, that circuit, the AND gate, OR gate, the complete logic gates will be present here. And before we give the data into this circuit, we have to store it here. Got it? And the output of this phase is going to be stored in the registers or the buffers associated with the next stage. R2 are the buffers for the C2, and R2 and C2 are combinedly called as stage 2. Got it? Similarly, stage like that we have n stages, and now all these stages will be managed by our control unit, and our control unit will give the timing signals and the control signals appropriately to see that the data will move between them accordingly. Now there are various ways here. What should be the time period of the clock? If you observe it, our main aim to design this pipeline is to see that the clocks per instruction is always 1. The clocks per instruction should always be 1. That is our main aim. We try to achieve it. How do we do that is, then how should we test or how should we set the clock is like this. Let us say for this unit the time taken is 10, for this one 12, for this one let us say time taken is 14. Okay, and since it is m units, assume that we have 5 units here, like stage 1, stage 2, stage 3, stage 4 and 5. First one is 10 and 12, let us say there is 13, maybe here one more is 10 and then 14, right? Which means, okay, I'm just assuming that we have 5 stages here instead of m stages. I'm assuming that there are 5 stages, and each stage control logic or the functional unit is taking 10 units here. Let us say this is 10 nanoseconds. Here it is taking 12 nanoseconds, 13 nanoseconds, 10 nanoseconds and 14 nanoseconds to perform its operations. Now what should be the clock right? So why is clock required is, whenever we enable the clock, then only the particular data will move from one register to the next register, or one unit to the next clock, like that. So what is the clock at which I should operate this entire pipeline? If all the stages are having uniform delay, let us say if all the stages are having the uniform delay of 10 nanoseconds, right, and assume that every register is going to add on for the load and read 1 nanosecond delay, then we know that every stage is going to take 11 nanosecond time, and we can set the clock frequency in such a way that the time period of each clock cycle is going to be 11 nanoseconds, which means then I can set that frequency equal to 1 by 11 nanoseconds. Are you understanding this? In case if all the stages are having the same delay, same uniform delay, then I can find out that uniform delay and I can set the clock in such a way that every clock cycle, every clock cycle will take 11 nanoseconds. So why am I doing this? So that every 11 nanoseconds one instruction will come out, then the clocks per instruction is going to be 1, isn't it? It is going to be true. But in case of these uneven delays, what should I do? If you try to fix the clock to the smallest required time here, let us say 10 nanoseconds is the least time that is required by any unit here. If I try to fix the time to 10 plus 1, which means 11 nanoseconds, then what happens is, in one clock, in 11 nanoseconds, this information will be pushed onto here, right? But then this particular clock, this particular unit is still processing, right? It didn't push out the data in order to collect this data. So that is why it will take there will be overlapping, and the pipelining will not function properly. That is the reason we always take the time period of the the largest time period required, and appropriately we'll set the frequency. In this case, if you watch it, the largest time period required is 14 plus 1, which is 15, right? So even though this one can finish in 10 nanoseconds, we still will set the clock to 15 nanoseconds, so that every phase output will be read after 15 nanoseconds and one instruction will be coming out every 15 nanoseconds. If that has to happen, then what should be the frequency of the clock? Frequency of the clock equal to 1 by 15 nanoseconds. So this is very important question, try to remember it. So what is it? When the pipeline stages are having non-uniform delays, then we are going to take the largest delay and appropriately we are going to set the frequency. Got it? Okay. And we can solve some questions on that also later, but first you try to understand this one. Numerical part we shall get into this later. I've just taken a small example of a two-stage pipeline to show you how it is implemented in the real world. We shall examine 3-4 pipelines. We shall take 3-4 CPUs and see how they are really implementing the concept of pipeline. For that reason I am taking this small pipeline. This pipeline is having 2 stages. This is stage 1. This entire rectangle is stage 1, and this entire rectangle is, let us say, stage 2. 2-stage pipeline. Now if you remember, we have discussed about micro instructions. In case of micro instructions, the best thing is we don't have to execute the instruction. We have to just load it into the register and automatically the decoder is going to generate the signals. That we have already seen it. If you remember, we have already seen this while discussing about the hardware design. Now assuming that we have such a micro programmed control unit, we are trying to pipeline that one. So since this is the basic smallest example, I taken this. So you need not by heart it, you need not do anything, just try to understand how it is implemented, right? So if you observe this one, this is the generic one and this is the practical one which we are trying to implement. Now if you see this stage 1, it is actually going to act as a fetch. So this is going to fetch the instruction and this one is going to execute the instruction, right? This is fetch, this is execute. Now for fetching, I told you that here every stage is going to have some circuit associated with that along with the resistor or the buffer. Now if you see this, the corresponding buffer for this phase is micro program control. So what is micro program control? This particular resistor will tell us what is the next micro instruction that has to be fetched from the control memory. Now what will be done in this logic? In this one, we'll pass this address into the control memory. If you remember what the control memory is, it is containing all the instructions, micro instructions, right? So that address will be given to control memory. As a result, control memory will give you that particular instruction, right? And that instruction will be stored in micro instruction register. And now this micro instruction register is going to be given to the decoder, and decoder will execute it. Execution is nothing but generating the control signals. Now if you see this, these two stages can be operated independently, which means if one instruction is here, then I can put next instruction here, which means if let us say I2 is here, then I can start fetching I3. So that is how parallelism can be done, and that is how we get the benefit of the pipelining. Even in this case also, why do you think that pipelining is going to be more useful is, at any time we can have m instructions being processed parallelly, right? So just observe this one. Let us say one instruction is being fetched here, at the same time some other instruction will be executed here. Got it? So that is how in practice we are going to have various functional units. These are all functional units, different functional units, and every functional unit is going to have a buffer, and every buffer, see, so this one is going to get some number, and from here this one is going to get some input, right? And this will process and will get to the next stage. In this case we have only two stages. In here, when you have m stages, some input will be given to this phase, and from here it will process it and give it to this register, and from this register input will be given to this phase, and again it will process it and give it to the next one. Likewise, the instruction will cross all the phases and it will come out of it. Got it? So if you understand this, I'll give you more examples. Let's take more examples and you will understand more. Okay, this is a simple basic one. So if you want to see how it is working, initially you can load it with some number, and that particular instruction will be fetched from the control memory, and that particular instruction from the control memory will be loaded into the micro instruction register, and now micro instruction register will decide what should be the next address. So that is why next address logic. While deciding this, there will be some conditions to be checked. For that reason we are going to use the flags. I hope you remember this one. We have a multiplexer here, and that multiplexer depends on number of flags here, right? And some of the bits will be used in order to select what flag it is, right? And then if you have to branch, sometimes you are going to load the branch address there, and decode is going to decode what action you are going to take based on it. Got it? So anyway, I'll take even more examples before going into the questions. Let's be thorough with the theory, then you will be very easily be able to solve some questions. Okay, before going into more examples, we can take some few examples based on this concept, how to set the frequency of the clock. Based on this one, we will take some questions. Later we shall see more examples of the pipeline, and then we shall see more questions. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177, and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.